All right, let's talk about something huge. We're diving into these incredible new techniques that are making it possible for pretty much anyone to customize and run gigantic AI models. Seriously, we're talking about putting the power of massive AI right at your fingertips. So let me just kick this off with a question that honestly would have sounded completely absurd just a couple of years ago. Could you train a 65 billion parameter AI on just a single graphics card? I mean, the thought of doing that without a whole warehouse full of servers, it was basically science fiction. But what if I told you it's not anymore? What if you could slash the number of parameters you actually need to train by a factor of 10,000? And no, that is not a typo. We are talking about a 10,000-fold reduction. This changes absolutely everything. So in the next few minutes, here's what we're gonna cover. We'll break down this amazing sticky note trick that makes AI customization super efficient. That's LoRA. Then we're going to see how you can train those huge models on a shoestring budget using QLoRA. And most important, by the end of this, you'll know exactly which method is the right one for your project. First things first, let's talk about the core challenge here, the billion parameter problem. Why has it always been so ridiculously hard and so expensive to teach these giant AI models new things? Well, let's compare the old way with the new way. On one hand, you've got full fine-tuning. Think of this like trying to rewrite an entire encyclopedia just to add a new chapter. It is unbelievably expensive, it's slow, and it requires a ton of heavyweight hardware. But on the other hand, we have the breakthrough, low-rank adaptation, or LoRA. It's fast, it's flexible, super efficient, and get this, it runs on about 3 times less memory. You know, the idea behind LoRA is just, it's genius in its simplicity. Instead of trying to change the entire model, you just freeze it, you block it down, and then you inject these tiny new trainable layers. The best analogy, it's like adding smart sticky notes to a giant textbook. You're not rewriting the book, you're just adding these small targeted notes to teach it something new. And the process itself is just so elegant. Step 1, freeze the original model. Its billions of parameters stay exactly as they are. Step 2, you inject those small, efficient adapters. And step 3, you train only the new adapters. And that right there, that's the secret. That's why it's so incredibly efficient. You're updating maybe a few million parameters instead of billions. Okay, so if LoRA was a really clever trick, then QLoRA is an absolute revolution in efficiency. This is for all of us who don't happen to have a supercomputer sitting in the basement. Now, before we get to QLoRA, there's one key idea you have to get: quantization. I know it sounds complicated, but trust me, it's not. All it really means is reducing the precision of numbers to save space. It's just like taking the number pi, and instead of writing out all those decimals, you just use 3.14. Yeah, it's a little less precise, but it's way smaller and much faster to work with. So you can probably guess what's coming next. QLoRA is exactly what it sounds like. It takes that quantization trick and smashes it together with the LoRA method. So to go back to our textbook analogy, now you're not just adding sticky notes to the textbook, you're adding sticky notes to a compressed 4-bit paperback version of that textbook. You are saving a massive amount of space right from the get-go. And what does all that efficiency get you? This. It gives you the power to fine-tune a 65 billion parameter model. Yes, that model from our first question. And you can train it on a single 48 gigabyte GPU. It was completely impossible before QLoRA. The secret sauce for QLoRA really comes down to 3 key things. First, it uses this special 4-bit format called normal float 4, which is just perfectly tuned for the kind of numbers you find in an AI model. Second, there's this clever math trick called double quantization, which actually compresses the compression data itself, squeezing out even more memory savings. And third, something called paged optimizers acts like a smart memory manager, stopping your computer from crashing when you're pushing your hardware to its absolute limits. Okay, so we've covered training. That's awesome. But what about when your model is done and you need to actually run it, in a real application? That's a whole different ballgame. So let's talk about serving models at speed with a tool called GPTQ. GPTQ is a post-training quantization method. The name says it all, right? This happens after you're all done with training. It's a one-shot deal that takes your finished model and shrinks it down to an incredibly lean 3 or 4 bits. The goal here isn't training at all. It's about pure deployment speed and efficiency. And that right there is the magic of GPTQ. It's just a final optimization step. You take your beautiful, perfectly tuned model, you run it through the GPTQ process, and out pops a smaller, faster version that's ready for the real world. No extra training, no new data, just pure, simple optimization. So we've looked at LoRA, QLoRA, and GPTQ. And that brings us to the most practical part of this whole explainer, your fine-tuning decision guide. How do you actually choose the right tool for the job? Well, it's all about matching the tool to your goal, and this chart makes it super simple. If you're training but you're on a tight budget with limited GPU memory, QLoRA is going to be your best friend. If you just want the absolute lowest cost to specialize a model, classic LoRA is perfect. If you're done training and all you care about is raw speed for your app, GPTQ is the answer. And if you need one base model to handle lots of different tasks, using swappable LoRA adapters is the way to go. All right, so let's boil this all down to your 3 key takeaways. Number 1, LoRA is the sticky note method. It adds tiny, trainable adapters to efficiently customize models. Number 2, QLoRA takes that a step further, letting you train massive models on consumer hardware by compressing the base model first. And number 3, GPTQ is your go-to for shrinking a finished model to make it fast and cheap to actually run. At the end of the day, what all these techniques, LoRA, QLoRA, GPTQ, really do is they democratize AI. They take this incredible power that used to belong to just a few giant tech labs, and they put it in the hands of developers and researchers and creators everywhere. They give you the power to build. So the only question left is, what are you going to build with it?